Hey guys, welcome to another section of video notes here, and now we're talking about these things called Atwood's machines. So we've talked about the inclined planes and then forces being pulled at an angle on our objects. Now we're talking about two objects over a pulley. It's kind of how elevators work. Let's just kind of jump into it. Here's the basic setup. We're going to have a massless, frictionless pulley that has two separate masses, and this is how this is set up, okay? Obviously, if one mass is greater than the other, it's going to cause the other to accelerate, right? So let's just say, for example, the first mass over here, this is 10 kilograms, and the second one over here is going to be 5 kilograms. Okay, so I have these two masses. What's going to happen is it looks like when this accelerates, the first mass is going to accelerate downward, and the second mass is going to accelerate upward. Well, I can see here that they're both connected by this string, so the tension in those two objects, because they're connected with the same string, it's got to be the same. So the first things we do is we look at the free body diagram of each mass to figure this out. So here's M2, and it looks like I have its FG, we'll call that FG2, and then its tension, and I know that it's accelerating upward. I have the first mass, M1, it has its weight, we'll call that FG1. We have tension pointing up, and once again, I know this one's acceleration is pointing down. So what I do is I write my equations using Newton's second law for each of these. So for the first one, everything going up minus everything going down, tension minus Fg2 is equal to m2 times its acceleration. I do the same thing with the first mass. Tension is going up, its weight is going down, but in this case, it has a negative acceleration. It is going down, so I have to indicate that using my negative A there. So I'll substitute a few things. This is M2G here equals M2A. This one is minus M1G equals negative M1A. And what we do is we're going to solve each one of these for tension, and then we'll be able to solve using a system of equations and make the problem pretty simple for us. Here, we'll use this guy right here. Tension equals M2A plus M2G. Then what I'm going to do is I'm going to plug that into this guy right here. So this whole thing goes into where that tension goes, so M2A plus M2G. The rest of this stays the same, M1G negative M1A. And so if you'll notice, I know what all of the masses are. I know what the gravities are. And so what I'm going to do is I'm going to try to get the A's all on one side of the equation. It looks like I'm going to move this term over and then move these other two terms over here. So my equation will look like this, M2A plus M1A equals positive M1G minus M2G. From there, I can plug stuff in. So M2, remember, was 5 kilograms. So this would be 5 times A plus M1, which was 10 times A. equals, and then we'll have, once again, M1, that's 10 times 9.8 minus M2, which is 5 times 9.8. So a little bit of math here, 15A equals, see, 10 times 9.8 minus 5 times 9.8 gives me about 49 over here. So acceleration is about 3.27 meters per second squared. That's pretty cool. Once again, over here, when I look at this, it looks like M1, this guy right here, he would be accelerating downward, and M2 would be accelerating upward. So we would find the acceleration using this system of equations thing. Then we would go back and try to figure out what the tension is. And I would plug it into either one of these. Let's just use this first one right here to find tension. Tension minus FG2 equals M2A. Well, now I know my A. Tension equals M2A plus FG2. And then what we'll do is we'll just kind of plug everything in. M2, that's 5. My A is 3.27. Remember, my FG2 is M2G. So my M2 is 5. My G is 9.8. So when I plug this in the calculator, let's see, I get about 5 times 3.27 plus 5 times 9.8. So the tension in the cord will be about 65.35 newtons each way. And remember, because it's connected, each one of these is connected by that same string, we're going to get the same tension for each one of those. All right, I hope that helps. We'll get with me when we start working on the problem sets, make sure it makes sense. All right, thanks guys, bye.